Nuclear waste, radioactive leftovers from power plants, sticks around for thousands, even tens of thousands of years. These materials are so hazardous that they must be isolated from people and the environment for longer than any civilization has existed. The challenge of what to do with this dangerous byproduct is one of the biggest dilemmas of modern science and engineering. So why not just launch it into space? Out of sight, out of mind, right? The idea sounds almost elegant. Take our most dangerous trash and send it far away, beyond the reach of life on Earth. It sounds simple. Pack it up, blast it off, and let the universe swallow our problem. No more worrying about leaks, storage, or future generations stumbling upon our radioactive legacy. But when scientists and engineers actually examine this idea, they see massive red flags. The reality is far more complicated than it first appears. The costs, risks, and technical hurdles are staggering. Rockets are incredibly expensive to build and launch, and every launch carries a risk of failure. A single accident, an explosion on the launch pad, or a crash during ascent could scatter radioactive material over a vast area, turning a local problem into a global catastrophe. The consequences would be unthinkable. The reality, shooting nuclear waste into space is far more dangerous than keeping it here on Earth, where we can monitor and contain it with strict safety measures. Before we start loading rockets with radioactive cargo, let's break down the science and the risks. What are the real challenges, and why do experts urge caution? How much waste are we talking about? What would it cost to send even a fraction of it into orbit? The numbers are mind-boggling, both in terms of volume and dollars, and what if something goes wrong? The risks aren't just theoretical. Rocket failures have happened before, and the stakes with nuclear waste are unimaginably high. Let's find out why. Despite the temptation to send our trash to the stars, the experts say, keep it on Earth and manage it responsibly, for our safety, and for the generations yet to come. Not all nuclear waste is the same. In fact, the term nuclear waste covers a wide range of materials, each with its own level of radioactivity, risk, and required handling. Understanding these differences is crucial to understanding the real challenges of nuclear energy. Most of it, about 90%, is low-level stuff. Things like gloves, tools, and protective clothing that have been exposed to radiation during routine maintenance. These items are only slightly radioactive and can be safely buried in specially designed landfills where they pose minimal risk to people or the environment. This kind of waste is produced in hospitals, research labs, and nuclear power plants alike. Then, there's intermediate-level waste, which makes up about 7% of the total. This waste is more radioactive than the low-level kind, but still manageable. It includes things like reactor components, resins, and chemical sludges. To keep it contained, it's often sealed in thick, concrete containers and buried deep underground, far from people and groundwater. The real challenge, though, is high-level waste. This is just 3% by volume, but it's intensely radioactive and remains dangerous for thousands, even millions of years. High-level waste is what most people think of when they worry about nuclear power. This waste comes mainly from spent fuel removed from nuclear reactors. It's made up of solid ceramic pellets, stacked inside long metal rods. These rods are so radioactive and hot that they must be handled with robotic arms and stored underwater to cool down. Every year, the world's nuclear reactors generate about 11,000 tons of this high-level waste. That's enough to fill a few shipping containers each week, and it all needs to be kept isolated from the environment for generations to come. Over the decades, we've accumulated around 400,000 tons of high-level waste worldwide. Most of it is still stored in temporary pools or dry casks at reactor sites, waiting for a permanent solution. When people talk about launching nuclear waste into space, they're referring to this tiny but extremely dangerous fraction. It's the part that keeps scientists and policymakers up at night. High-level waste needs heavy shielding to protect workers and the public, constant cooling to prevent overheating, and a disposal plan that can last longer than any civilization in history. The problem isn't the sheer volume, it's the danger, the complexity, and the unimaginable timescale over which this waste remains hazardous. This is the waste we need to solve, a challenge that will test our technology, our planning, and our responsibility to future generations. Let's talk money. Launching anything into space is wildly expensive. It costs about $4,000 per kilogram just to reach low Earth orbit. With 11,000 tons of new high-level waste each year, that's $44 billion annually, just for launches. That's more than NASA's entire yearly budget. And it doesn't include the cost of rockets or ultra-strong containers, and we still have a 400,000-ton backlog, which would cost trillions. For comparison, making the fuel costs less than half that per kilogram. The economics are absurd. We'd spend more to throw away the waste than to make the fuel. Nuclear energy would become unaffordable overnight. The cost alone makes space disposal a non-starter. Before we even get to safety, the price tag kills the idea. It's just not a responsible use of resources. Even if money was no object, we hit another wall rocket capacity. In a record year, all the world's rockets combined could lift about 800 tons to orbit, but we produce 11,000 tons of high-level waste every year. We'd need to launch 14 times more rockets, thousands per year, just to keep up. And that's not counting the heavy shielding needed for safety, which would multiply the number of launches. The logistics are impossible with today's technology. We simply don't have the rockets, or the infrastructure, to make this happen. Let's say we solve cost and capacity. Where do we send the waste? Low Earth orbit? Bad idea. Everything up there eventually falls back down. We'd be creating a radioactive threat hanging over our heads, just waiting to re-enter. The moon? It's expensive, and we'd be contaminating a place of scientific value. A crash landing could scatter radioactive debris across the lunar surface. The sun? Ironically, it's the hardest target. Canceling Earth's orbital speed takes more energy than leaving the solar system. Miss, and the waste could end up in an unstable orbit, threatening Earth centuries later. Every destination in space comes with new, unacceptable risks. There's no safe cosmic landfill. The universe isn't our trash can. Here's the scariest part. Rockets sometimes explode. Even in a good year, launch failures happen, about 7% of the time. If a rocket carrying nuclear waste explodes, it could spread radioactive dust over a vast area. It would be like detonating a dirty bomb, contaminating land and water for generations. A high-altitude failure could spread fallout across continents. With thousands of launches needed, even a tiny failure rate means regular nuclear disasters. We'd be gambling with the planet's safety every time we launched. The risk of a single catastrophic failure outweighs any benefit. We'd turn a local problem into a global nightmare. It's a risk humanity simply can't take. So, what do we do with high-level nuclear waste? It's a question that's challenged scientists, engineers, and policymakers for decades. The waste from nuclear power plants is highly radioactive and must be isolated from people and the environment for thousands of years. But despite the daunting challenge, we actually have practical, proven solutions right here on Earth. The best answer is deep geological disposal, burying waste in stable rock formations, hundreds of meters underground. These repositories are designed to keep radioactive material safely contained, far from groundwater and the surface, for millennia. These sites are chosen for their stability, no earthquakes, no volcanoes. Geologists spend years studying the rock, ensuring it's been undisturbed for millions of years and will remain so long into the future. Waste is sealed in robust casks, then entombed in tunnels and surrounded by layers of clay and rock. These multiple barriers work together to prevent any radioactive material from escaping, even if one layer fails. Countries like Finland and Sweden are already building these repositories, setting a global example for safe, long-term storage. But deep burial isn't the only option. Another promising solution is recycling spent nuclear fuel. About 95% of spent fuel can be reprocessed and reused in certain advanced reactors. This process extracts valuable materials, turning what was once waste into new fuel and reducing the amount that needs to be stored. Recycling not only shrinks the total volume of waste, but also makes better use of our resources, helping to close the fuel cycle and minimize our environmental footprint. And remember, other industries produce far more toxic waste. Coal ash, for example, is generated by the billion-ton every year and often stored in open pits, posing risks to water and air. The nuclear waste problem is serious, but it's manageable with careful planning, strict regulations, and ongoing scientific oversight. We have the knowledge and technology to keep people and the planet safe. The real solutions are here on Earth, not in the stars. We don't need to launch our problems into space, we can solve them with smart engineering and responsible stewardship. Science and engineering, not rockets, will keep us safe, now and for generations to come.